Assalamualaikum and hi everybody. Today our group will present an analysis of cellular manufacturing using the rank order clustering method and Hollier method. So this method helps us group parts and machine efficiently to improve manufacturing flow. Okay, this is the presentation outline. Okay, this is the analysis of cellular manufacturing. It is a structured assessment to deal with problem in group technology and cellular manufacturing. So the objective is to reduce the setup time, material handling, and improve workflow by processing similar parts together. So there are several techniques used in group technology to group parts and machine into families. So these methods help us design efficient cellular manufacturing system. Okay, the first technique is rank order clustering. So they use the binary weights to iteratively sort the machines and parts of the machine part into incident matrix. So the output here is to the block diagonal matrix that visually identifies the cell. The rank order clustering is widely used because it is simple, effective, and easy to apply, which is why we use it in our case study. Rank order clustering was first developed by J.R. King in 1980. It is a heuristic method that exploits the structure of a binary matrix to identify the natural cluster. So this is our case study. We need to apply the rank order clustering technique to the part machine incident matrix in the following table. Okay, so in this case study, we apply the rank order clustering to part machine incident matrix to group parts and machine into families. So on the left, we list the pump parts. There's P1 until P6 parts, and the right table is a machine, what type of machine we use. So we list here, there are 7 machines. So from M1 to M7. So the table on the right is the part machine incident matrix. Each row represents a machine and each column represents a part. For the step 1, so in each row of the matrix, the series will put the 1 and zeros from left to right. So which means the 1 is for a product that processed by a machine and 0 for a product that is not processed by a machine. Okay, for the steps 2, we assign the binary number to the corresponding column. So starting from right to left, we start from 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4 until 2 power 5. So for each row, we add the binary weights where the value is 1. So for example, for machine number 1, only part 1 has a value of 1. So which corresponds to 2 power 5. So the decimal equivalent is 2 power 5 equal 32. So we go to the next machine, so M2. M2 here, we have the value number 1 for part number 2, part number 3, part number 4. So we calculate here, when part number 2, 2 power 4, 2 power 3, and plus 2 power 2. So we need to sum all the value here, and then we got 28. Once all decimal equivalent are calculated, we rank the machines from the highest to the lowest value. So we rank the machine from the highest to the lowest. Mean the highest value we rank first. Okay, this next step is we reorder the row in the part machine incident matrix by listing them in decreasing rank order, starting from the top. Here is the rank. We're starting from M4, M6, M1, M2, M5, M7, and M3. So next, after we reorder the rows, we write the binary values of each rows, starting with 2 power 0 from bottom to top. So we can get, for example, for part 1, there is number 1 for machine 4, machine 6 and machine 1. So we need to calculate the value here. Okay, for example, for part number 1, so we have 2 power 6, 2 power 5 and 2 power 4. We will get the 112. It goes to the part number 2 here. So the part number 2, there is number 1 for 2 power 3 for M2 machine, M5 machine, M7 machine. So we need to calculate here 2 power 3 plus 2 power 2 and plus 2 power 1, so equal 14. So we need to calculate all the P1, P2, P3, P4, P5 and P6. So the decimal values of the columns are then ranked in decreasing order as shown at the bottom of the table. So the next step is we check whether the current order of column match the rank order obtained from the previous step. If the order is the same, the clustering process can stop. If no, we need to go to the following step, meaning we need to reorder again the columns in the part machine incident matrix by listing them in decreasing rank order starting with the left column, meaning we need to go to the step 1 back. So for this case, already obtained the column that match the rank order obtained from the previous step. So here we already got a clear final block diagonal structure. So there are two groups structure here highlighted in yellow. Okay, so the result of the rank class of clustering, we have two part family here. For part family number 1, it include the part 1 and part 6. For machine number 4, 6 and 1. For the part family 2, we have part 2, part 3, part 4 and part 5. For machine M2, M5, M7 and M3. What to identify from the rank of order clustering? So first we can group the machines. So from the part family 1, we rank the machine number 4, 6 and 1 into one group, and we group the part 1 and part 6 into the group. For the part family 2, we group the machine number 2, 5, 7, 3 and part number 2, 3, 4 and 5. So from this ROC, we also can obtain the exceptional elements, means that appear that the one entries that appear outside the main diagonal blocks. So however, in this case, we have no exceptional element in the outside of the block. So for the voids, means the zero entry that appear inside the main diagonal blocks. There are 1 voids here for part family 1 and 6 0 appear in the part family 2. This represents the unused machine capacity within a cell. While the machine is dedicated to the cell, it is not required for a specific part in that family. Voids indicate potential underutilization or machine dedication that is not fully justified. Thank you from my part. Next, continue. I pass to my friend for Hollier method.
So, thank you, my friend Shazana, for explaining about the ROC. Now, I've continue with the Hollier method. So, in cellular manufacturing, the Hollier method is a simple heuristic used to sequence a machine within a manufacturing cell to improve the material flow. So, there are several advantages with the Hollier method that we can use, we can define in the Hollier method. So such as improve the material flow efficiency, reduce material handling and travel distance, and also easy to apply and understand. So for Hollier method, in our case study here, so we have four machine 1, 2, 3, and 4, and also part 1, 2, 3, and 4. So next. And this is the initial arrangement that we have. So what the most important thing in the Hollier method is to find the most logical sequence using this method to perform below from to chart table. So next. First of all, we remove machine and parts, and then next, we will have this kind of table, which is we have machine replaced with from, and also part we put a to statement on the top to as a reference. And then next, we need to identify from sum. So how to get the from sum? We need to have to perform the additional value in corresponding row. So all this row need to perform summation. And then next, how to get to sum? Next, additional value in the corresponding column. Alright, from this table, we will do a summation for to sum and also from sum. For to sum, for column number 1, we will get 70. And then for column number 2, 10 plus 75, we're going to get 85. And then for number 3, 80 plus 20, we will get 100. And then for number 4, we will add 85 plus 10, we got 95. And then next, for from sum number 1, we will need to add 10 plus 80, we will get 90. And then we will have 85. And then 70 plus 20, we will get 90. And also number 4, 75 plus 10, we will get 85. After we perform the summation here, so we need to perform from to ratio. So how to perform from to ratio? From to ratio is equal to from sum divided by to sum. So first step, from 1, 90 will divide by 70. And then continue with 85, divide by 85, and then we got from to ratio equal to 1. And then next we do for the next row is 90, divide by 100, and then we will get 0.9. And then for last but not least, for from 4, 85 divide by 95, so we will get 0.85. So after we got from to ratio here, next, we will perform the machine we will get the machine logical sequence. By how? We need to perform or arrange the from to ratio value by descending order. So by here, we will got the sequence 1, 2, 3, and 4 here by descending order. So the final machine logical sequence will be next 1, and then 2, and then 3, and 4. In short summary, we can say that the advantage of the method is to provide a simple way to have a sequence machine in serial layout. And also we can reduce the material handling and improve workflow efficiency with minimal data and computational effort. Thank you.